I have Bresenham's algorithm up and running, so let's have a little look. Now the example that I worked through, I also worked through within the tool which I've showed you in a previous video. So here are the points which I work through. So I start off at this point 0, 0, and it goes up to the point 28, and it goes along 12. So you can see here that it counts along, and you can see the route that it takes via Bresenham's algorithm. So it goes up 2, along 1, up 2, along 1, and then up another 2, and then up 3, and 2, 2, 3, 2, 2, 3, 2, 2, 2. So it means that if I was to do the same line within my CPU, I should get the same results. And in fact, I've actually done this here. So this is the line drawn within the CPU. So you can't really see it very clearly here, but if I zoom in it, I'll zoom right in actually, and we'll have a look at it. So if this is working properly, then it should be running up in the same route that we have here. So let's see if we get it over here actually. So you can see here that it's a bit small, but you can make it out. You can see that I've got it's gone up by 2 here, and then 2, and then 2. The same here, 2, 2, and 2. And then it's gone up by 3, and then 2, 2. So 3, 2, 2. And then it goes another 3, 2, 2. So that's that 3, 2, 2. And then finally there's a 3, and a 2, and a 2, and a 2. So it goes up 1, 2, 3, 2, 2, and 2. So you can see then that the Bresenham's algorithm is indeed working. And in fact, I've tried it in all different gradients, and it does work fine. Now, I will update the Design a CPU 2 course with a couple of videos so on this Bresenham's algorithm, so the final version of it. But one thing to note, and again I'll put this in the update to the course, I had to change a couple of things in order to get it working. So there were a couple of little things that were amiss. One of them was within this graphics card. So if we get into the graphics card here, you'll see I've actually added a little section to it. So I've added this little section here. So I've added this AND gate to the input of this JK. Now the reason for doing that was that originally this AND gate wasn't there, and this control signal was coming in and it was pulsing just randomly. So it meant that these values here at the output of this JK flip-flop were pulsing randomly as we ran the code. And we didn't actually want that, because it meant that whenever we actually pulsed this value here, when we did want to use it, then this would be sitting in some random position. So what I had to do was I had to take the output from a certain point. So I took the output from here, and at this point here, whenever this has gone high, we know we've chosen this card, and at that point only do we want to be able to pulse this JK flip-flop in order to choose the enable for the color and the enable for the X and Y coordinates. So that was one thing that was wrong, and it was preventing me from generating the line properly. Now there was another thing that was wrong, and it actually escapes me for the moment. Let's have a look and see. Now yeah, the other thing that was wrong here was that we had a carry out getting fed back in as a carry in to the ALU. Now we're not using the carry out and carry in for the moment. We will be using it potentially in the third course whenever we decide to do integer arithmetic, but we want to be able to do it more accurately. So rather than having, say, a 16-bit addition, you could have a 32-bit addition by using the carry out back into the carry in. but we're not doing that for the moment. And what was happening was we were getting random carry-in signals, and these random carry-in signals were coming into the adder here. So you can see the adder at the bottom. So it meant that whenever we were doing the additions here, sometimes we had a carry-in coming in here, and it was messing up the program. So what I've done is I've just tied the carry-in to a value of 0 for the moment, because we're not really wanting it until we go on to the next course, and we can deal with that when we hit the next course. So those were the two things I had to adjust in order to get it working within the CPU. And then of course I had to actually write the code for it. So the code is here, and I will go through the code in more detail within the course, but that's the code here, and actually it's the longest piece of code that I have written, and I'm quite pleased that we managed to get it working. So that's our machine, our assembly language code here, and the actual algorithm, if I've still got it up here, let's have a look and see. So this is the actual Bresenham's algorithm that I used, okay? So this code here in Python has now been coded into our assembly language, and it's been assembled. I've loaded it into the CPU, and I've ran it for lots of different X and Y coordinates, and it's working fine. So the Bresenham's algorithm is almost complete, because what I need to do now is take it from the code here and actually generate a subroutine. So that's no big deal. So I will generate that subroutine for this tomorrow. And there's one other thing I will actually do, and that is I'll change the starting position. So as we have it at the moment, the starting position for this graphics card here is the top left hand corner is 0, 0, and then it runs all the way down to 256, 256. But really what I want to do is have the origin here right at the center being 0, 0, and then it means we can go up plus 128, we can go down minus 128, we can go this direction minus 128, and we can go that direction there plus 128. So we just have to change the actual start position, but that's going to be relatively straightforward as well. And once we've got that done, that's the Bresenham's algorithm completely finished and out of the way, and we'll do a few wee drawings with it. And of course I will go ahead and update the CPU to design course. And this will be the last video actually within that course, and I will head on to the Design a CPU 3, where we will extend on the graphics library, and we'll add in some other graphical functions, and we will extend on the maths library, and we'll add in those mathematical functions, and possibly within that course we'll implement the floating point unit, and we'll create the floating point versions for these algorithms as well. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.